I'm going to illustrate how we can manipulate the target profile in Sketch-a-Filt for the design of a particular IIR filter. What I'm going for is a CCITT template here for the pulse code modulation filter, which figures in work of YC Lim and other researchers, and it's got this 30 dB, as you can see, 30 dB side lobe level, sample frequency of 32 kilosamples per second. Quite narrow, of course, passband up here. I've drawn this in MATLAB. I can go and capture it so I can use it now here in this CPIC window, which is open over here at the moment, and simply paste it in. And I can see that this filter, which is coming up, is not a very good one at all. I'm going to want to do a whole lot better than that. So I fold this away, bring in Sketch-a-Filt, and I can see that this filter, which is just a simply default frequency sampling filter, coming in with a brick wall cutoff of 4 kilohertz. I am putting a lot of coefficients into it, in fact far more than strictly necessary, because I'm going for 99, and I know it can be done for as small as 35 coefficients, but I'm going to make use of this high order FIR filter to bring about an IIR design. I'd like something a little bit more responsive to me than frequency sampling, so I'm going to call in a particular type called weighted least squares from UserDef, bring that in and get rid of frequency sampling, and see if I can redraw this segment of the red target profile to get a better situation. I'm coming down here like so, and I'm finding out that I've already managed to bring the passband ripple in and actually make use of this little staircase area here. This looks quite good insofar as the passband goes. Let me go deep down here by changing my scale, and down below that 30 dB point, and I can find it's not too wonderful down here. Let me redraw this as well so that I bring this area more under control, and try to make more use also at the same time of the transition area. Wow, I've done a great job there. Haven't put too much effort into it. I've brought this in already. If I want to manipulate this and get this side lobe down even more, I can move this up, and this probably would then let me persuade this to come down a little bit deeper. Let me just check, see what's happened back in the passbands, make sure I haven't pulled that out, which of course can quite easily happen. No, I'm in good shape there as well. So I've got myself a quite large filter, FIR. I'm not too happy with the terrific burden of multiplies that implies. So I'm going to try to have Brandenstein, that is to say Brandenstein-Unbehauen technique, bring this into play to try to emulate the FIR filter with maybe say a 12th order IIR. Well, you can see that's a very terrible job it's doing. But on the other hand, we expect this with Brandenstein because we're attempting to design an IIR linear phase filter where all the impulse response is peaking up in the middle, when in fact we should be trying to get a MIP filter, a minimum phase filter. So I just changed this to my target. So now I've brought the UserDef design into minimum phase, and of course now Brandenstein comes down much smaller and is looking quite good. I can look in here and put my template back on, see what's happening, and indeed everybody's fitting. Both of these filters are fitting insofar as both the stop band and the pass band. Let me see if I can get away with fewer coefficients down here. Let me go to about 9 or something, and this hasn't dramatically disturbed things. It has a bit down here in the stop band, so let me go down deeply and see what's happened there. Should be able to get this size down quite nicely. Oh, it's still fitting in, so let me just check that by dropping back my template. Yes, it is fitting. So let's see if I can get by with even less. What about sixth order design? And drop it back on again, paste that, and indeed it seems to be fitting. Let me zoom also into the passband and see what's happening there. And I see that indeed, sorry, I should have zoomed that, and see that indeed is fitting quite nicely. So let me get rid of the FIR and see only the IIR. And I can see that there's not a lot of redundancy in it because my poles and zeros are in different places. So I've probably got about as small as I can get by with. I've now got the sixth order Brandenstein-Unbehauen, so roughly speaking 12 multiplies instead of an FIR design, which would require something like 35. And this then is one way to design this filter. And you notice we've simply manipulated the shape of the target profile to make this happen.